DIPAS is a platform that provides means to do this. And more importantly, a key requirement for DIPAS is to keep it low level, that no one should register to take part in the process. So it's an open platform. We have georeference contributions. That means everyone who writes about a topic, about the idea he likes to share, can pinpoint his idea or his contribution to a location on the map. For the map, we use another project of our department, another product that's called the Master Portal. Sounds amazing, right? It's something like Google Maps with urban data. And that's nowadays the main key part of DIPAS. It is designed to work on multiple purposes and proceeding at once. So back in the days when DIPAS started, you had one proceeding which equaled one Drupal installation, one database, and the whole overhead. Nowadays, we have only one Drupal installation and one database for all proceedings. The technical foundation, currently, we're still on Drupal 10, although our custom code is already Drupal 11 capable and ready. So the transformation and the migration to Drupal 11 should really be not that much of a hassle. There just has to be some time found to do it, right? it's like always the same thing. Where's the time to do things? For the multi-proceeding architecture, we implement the Drupal domain module. I guess most of you may have heard about it. And we wrote some custom modules which implement a custom REST API that features plugin architecture, which I will comment on further down the road. And we use Symfony events. As I mentioned, we also use the Master Portal. That's our map application to visualize the data and also visualize other urban data as well, which also has its own. It's also open source. You're welcome to check it out. It's freely available on masterportal.org. And in the front end, we don't use the Drupal rendering layer. Has some historical reasoning behind. As I started with the department a couple of years ago, I was the only one who was capable of programming for Drupal 8. And I don't wanted to do all the work alone. So I opted for a fully decoupled system with a front-end single-page application written in Vue.js version 3, so others could help in developing it. And both Drupal backend and Vue.js frontend communicate via our own REST API using JSON as a data format. Okay, now we're not talking about DIPAS as a whole, but about a sub-project within DIPAS. What is DIPAS Analytics? DIPAS Analytics should automate the analysis of the data that citizens bring into the proceedings. If I ask you, for example, what should I do different about a certain topic? It's quite easy to recognize what you want and to formulate plans upon that. If I ask 10 of you, it gets quite more complicated because you may have contradicting opinions and it gets quite messy to filter out the comments and ideas. And DIPAS Analytics goals take into account that we use AI to extrapolate, to extract the key messages within the contributions, which are free text. So you can write like an email. You don't have to fill out the form. You can write like an email. It's free text. You're free to use whatever language you want. And we use AI to extract the key points of your contributions. We do live monitoring because DIPAS has as a key requirement that you must not authenticate or register with our platform. It's like an open door for like spam and such things, or like maybe data or contributions that are not quite that likable. So we do live monitoring to remove, like, for example, personal information. If you want to share your bank information, that's okay with you, but we don't like to have this information on our platform, so we do some live monitoring to enable us to extract the data. We have, as I mentioned, the automated data analysis and extraction, and we extract the key messages from each contributions, the sentiments, and the thematic aspects that are contained within, using AI, obviously. And that's the most central point in it all, don't rely on AI alone. Always keep a human in the loop. A human should always be capable of redacting and correcting data coming out of the AI. Okay, just a brief overview on the architecture and the modules. As I already mentioned, I'm only talking about the DIPAS Analytics, so these are not the only modules we wrote for DIPAS. It's only the Analytics suite. We got a layer model in place, so we are using several different techniques from Drupal. Obviously, we have a Drupal and a database installation, otherwise we won't be here, right? We use services, the Drupal standardized services. We have a request handler that enables or bundles the communication with external services. We have an orchestrator that's in place to like orchestrate the different features and mechanics that are taking place. We have an edit session service for monitoring and providing undo redo capabilities for editing the AI data. And at least for the editing sessions, we have also an action API. That's a layer that is targeted towards providing capabilities like renaming something, like merging data or something like that. We have a plugin system. More about that later. It's just a quick overview. We have config sections, we have AI plugins, and the list and edit sections. Config sections, DIPAS Analytics consists of 3 different modules. One base module providing a core infrastructure for the project, and 2 separate modules, one for the live monitoring and one for the data analysis part. And each of these top layer modules provide config section plugins so that the configuration of the AI suite can be done from a single place. We have AI plugins. These are the modules that concentrate all the work that has to be done with the LLM backend. And at last, the list and edit plugins are the plugins that editors use when editing the data. More on them later. Of course, in order to do that, we have to have a REST API. The REST API here is the API that we implemented in order to provide AI plugins to communicate with external remote AI backends. And we have the Action API, yet another fancy API, a REST API that is. It's a synchronous API, also JSON-based, that handles requests for data editing sessions. And in terms of the front-end UX for the editor, we have single-page applications in place. Also, we're not using the Drupal rendering layer here because it was just easier to spread the workload and to reuse components we already had. Okay, plugin system. As I already mentioned, we have 4 different plugins. The key principle constantly and thoroughly follows the Drupal design principles. We use an annotation class. We use a plugin manager service that provides the Drupal site integration for these plugins. And each plugin type has a base class so that we don't have to reinvent the wheel every time we have to want to write a plugin. All certainly discoverable by namespace convention, like always in Drupal. As I mentioned, the AI configuration section is a plugin type that tends to or is intended to integrate different AI models into a single place of configuration. Its purpose is to keep the complexity of the config form low. As you can imagine, when you have the whole suite is intended to be extensible, and the more modules you have, the longer the configuration section would tend to get. And the configuration section plugins delegate configuration elements to those respective plugins. So each plugin, each module takes care of its own configuration, but hasn't to do anything to do and to keep the workload with storing the configuration and retrieving it and editing it. All this is taken care of by the base module. We have the AI plugins. These are the key building stones for the communication with the external LLM services. These plugins provide key methods. They can answer, am I ready for an analysis? The return, obviously, a Boolean value. Am I ready or am I not ready? Is my analysis finished? Also Boolean. Initialize analysis returns a bunch of job IDs, more on that later, and place AI response, a method where the answer of the LLM service is then placed when it arrives. No? Why doesn't? No. We have analytics list action plugins. These are plugins used in the editing sessions. These are plugins that act on data read-only, so they're only retrieving data according to given specifications. And we also have analytics edit action plugins. These are plugins that actually can act on the data, that can edit data, create, rename, update, merge, delete. And these plugins require the session authentication via Drupal. So you have to log in to use them. And also they support under redo, which I will comment on later. Then let's talk about the key principle of the AI analytics pipeline. How does actually an analysis work? First, the kickoff. A point in time when it is determined that the proceeding can be analyzed. This is, I'm not talking here about the live monitoring, I'm only talking about the extraction of AI data, which is the more juicy part. And for that, you have to have a completed proceeding, so a complete data set. And this kickoff event is triggered by cron. Cron determines this proceeding now is finished. All data has been collected, and also the orchestrator determines which AI plugins can be fired right away, which have no dependencies at all. After determining the plugins, it calls initialize analysis on each of them. Then, an HTTP request is fired. The Drupal backend sends the data to the LLM backend for analysis, and the LLM backend answers with a job ID. As you can imagine, if you have thousands of contributions, analysis of these contributions takes quite a time. It's not seconds, it's not minutes. Sometimes it's not even hours, sometimes it's days. So we are returned the job ID. Half a day, 1.5 days.
I've done some automated version.
Yeah, okay. So we get a job ID in return, and at our side, at the Drupal side, we store this job ID along with the plugin process identifier that initialized the request. So when the LLM backend answers, it answers with the job ID and the answer data, the process data. So we can match who requested it, and we can port it back then. As I told also, it's an async pushback. After some hours pass by, it's the LLM backend that initializes the request back to the Drupal side with the job ID. And the request handler now dispatches firstly a Symfony event to all it who may take interest, and naturally it will place the answer data to the plugin that initialized the request. Next, after the answer was placed, the orchestrator gets triggered again, and now looks, are there more AI plugins that now are ready for their analysis? Plugins that may have had a dependency on another plugin. And if it's the case, it collects these plugins that now are ready for the analysis and triggers them with initialize analysis. And this cycle repeats until no plugin is left. Then the analysis is considered complete. Okay, I also mentioned the edit session plugins feature an undo and redo capability, and also the edit sessions have to be guarded somehow. Why? Because we purposely chose to refrain from using the Drupal entity system. We didn't want it to have all the entity overhead, like events. When an entity is created, Drupal fires internal events. When an entity is updated or deleted, Drupal fires internal events. We wanted to keep the whole system lean, and we have therefore custom tables, because we also did not have any need for all this overhead, like revision system and so on, and translation. Therefore, our edit sessions are shielded, and there's an edit session lifecycle. A user starts an edit session. The backend answers with a UUID token. In order to start an edit session, you have to be logged into Drupal. So that's the authentication layer from Drupal we're using to authenticate the users that are allowed to edit the data. Plus, they get an UUID token in order to distinct or to tell, okay, this user may edit the data now. He has the token. No other one can edit the data at the same time. Not even the one having the edit token in another browser or another browser tab. It's like the Highlander principle. Only one browser app or browser tab is allowed to edit. We have edit actions. These need the tokens to evaluate if the edit action that's taken place is allowed to take place in the first place. And also each edit action refreshes a timestamp when the edit session was last used. So each edit session has a time to live. If it's not used, in our case we configure 30 minutes, it will expire. So there's an auto logout feature. We have also the action to actively end an edit session, obviously. So if an editor says, okay, now I'm done, he can actively log out and enable others to start editing session on their own. And this edit session end event also clears remaining undo or redo elements in the timeline, because these are session bound. As I already told, there's a mutex guarantee, mutex, mutual exclusion. So a second user can't start an edit session because it's already blocked, and the editing user can't also start a second browser tab to continue editing in two places, because this is potentially will result in conflicting data, and this is why we implement features to lock them out as far as possible, so just one browser tab is possible. Okay, lastly, the undo redo system before I hand over. It's, I guess, quite unusual, but practical and works like a charm. On each edit action plugin returns an undo redo object. That's just a generic PHP object. This PHP object contains two query stacks. You all know the Drupal database abstraction layer, like database query, or database update, or select, or whatever. And each edit action plugin creates an arbitrary PHP object containing two of those request stacks, one for undoing the edits the plugin has done, and another one for redoing the same thing that just has been done. These get stored to the database in a serialized manner. So alongside with the name of the action, you get like a stack of queries that needs to be fired and executed in order to undo the last action, as well as to redo the last action if it was undone before. The Action API stores that in the database, and of course, each of those query stacks are bound to a specific edit session and to a specific user and proceeding. Yeah, if the client calls undo, you just take the last undo action. You take out the query stack for undoing, you execute the query stacks for undoing, and then you mark the action in the database as redo. So if it calls redo, you can take the other query stack you have also provided and just redo all the queries. Yeah, and a new edit after an undo, if you do another manual edit, just invalidates all remaining redos, because then the history diverges. It's like Photoshop. I guess most of you know it works the same way. Okay. The AI pipeline. Ah, that's your part.
That's my
Okay.
So, all right. So now I talk a bit not about Drupal, so we go a step back and we are just looking into how the AI pipeline is working behind the scenes, as you may will so. So what we have done is we had a lot of discussions. How can we get this problem done? How can we provide a solution? And we have spoken with the urban planners in our department and in our city, and they told us, okay, well, we asked them what is the most valuable or the most value that you can extract from these contributions. They told us 3 types they need to know, because when they know these 3 types, they can do something with their urban planning. And one type is the description of the situation, like the street or the crossroad. There are traffic lights, but I feel some kind of unsafe. Yeah? Another one is suggestions, like I feel unsafe, but it would be nice if there are some kind of barriers to walk, you know, or to get the cars not across this kind of limit. And sometimes we saw that there are some kinds of questions in the contributions, like here's why, here are so many squares sealed, yeah? Because why is no green place there, for example? All right, so they told us, okay, this is the most where we can get out of contributions, and as Christian already told, we have a lot of contributions. And the system is very, very, very being used. So one proceeding is in average 300 contributions. And if we come to some category of mobility, it's more than 1,000 contributions. So for a normal person, it's not really good to handle this. All right. This is why we have thought about, okay, we should look into these contributions. I know this is here in German, but I have translated it in English. And we have seen that always in these contributions there are some kind of key messages, yeah? Some phrases that point to one point that they want to talk about. Okay, and our goal was to look for these key messages and bring them together. Like, we bring them together and we call that aspects. Yeah? So we have these contributions, we have in contributions these key messages, and somehow we want to put these key messages together to an aspect. All right? Okay. So, and as Christian also mentioned, this is really important. We have every contribution has a georeference. So if you go on the DIPAS system as a citizen and you type in your contribution, you always are forced to make a geo point. Yeah? So for example, okay, at this crosswalk here. And we come up with our high-level contribution analysis where we take this contribution. First of all, we developed a service for extracting these key messages. So we give our model the contribution and some kind of extra context. Yeah? So there was a history as we developed this service, because at first we just thought about, okay, we take a contribution, we put it in sub-sentences, and maybe then we can get some kind of value out of it, okay? And we paraphrase it and so on and so on. So I think I have 50 minutes, right? Yeah, okay, so. Then we did several iterations, yeah? And at least we came up with this, so actually I think it's half of a page of the prompt, yeah? Where we say, okay, here's the contribution, divided in some kind of sub-sentences, do a paraphrasing, specify a JSON structure, this is only for the output, added additional context, like the proceeding description, because we have seen that the proceeding description was good for the model, yeah? But there was also some kind of interaction, because the proceeding owners, usually they only type in for the proceeding description something like it starts at this date and it ends at this date, but no really context about the proceeding. Yeah? So we have to talk with them. Please provide more context for the proceeding. Like it's about mobility in the part of the city of Hamburg, and we are the goal is to improve bicycle lanes, for example, right? So. And also, we have seen that we should give the model some kind of rules. So it's like first do this, second do this, third do this. Then, in another step, do some kind of self-assessment, like have you done this, have you done this, have you done this, have you done this, and so on. And then the result was okay for us, yeah, because actually in AI you can improve your result every time, but we had the need to go to production, okay. Wait a minute. I try to connect to the VPN. All right, it's not. So, okay, so we have the extraction of the key messages from the contribution. We have also the related sentences. So the related sentences are always the relation to the original sentence for this key message in the contribution, right? And as I told you, the stakeholders said to us, we need these three types. So we have trained a model, which we call statement labeling, or services statement labeling, where we classify each sentence in these three types. Yeah? So we asked our stakeholders to annotate 1,000 sentences, and then we have trained our own model. So this is not really a large language model, it's a small model, but we have trained it so it can do the service. All right? Okay. So we have this extraction of key message, we have the statement labeling. Then in DIPAS you can choose a category. If you put in your contribution, you can choose a category, and these categories are provided originally from the proceeding owners. And it's like mobility, green parts, and so on. Yeah? So that's really good. But the thing is that we have seen that in these contributions, the people are not only talking about green parts or mobility. Usually it's mixed. This is why we have also done a service or implemented a service which is assigning a category to these key messages. So we have the key message with a category, and we have the related sentence with a statement. Okay. All right. So, and then, as I told you, the goal is to get these aspects and somehow to get these aspects into clusters. Right? And for example, here we have like loud sidewalks get blocked by parked cars, so this is key message from a contribution, or parked cars and trucks not to the view. They have a situation description. Here is the problem. Here's the quality and quality. At this stage, our stakeholders told us, okay, it also would be good not only to have the statement labeling, but also for the key message to have some kind of type as well. So, for example, they told us sometimes it's good to have the type of quality. Yeah? Like you can see here, the favorite spot of everyone in Fußball. Fußball is a district in Hamburg, and they like there at this spot. So it's not there, it's more a good spot, but sometimes there are also there. Okay. And then we need to put these aspects into clusters, and this is why we have another service implemented, which is grouping these key messages, similar key messages together. All right? And as well, doing the title generation. Yeah? This is what you see here. The parking situation could be improved, traffic lights, not pedestrian friendly, and so on. So it's valuable for the urban planners. Okay, just to summarize, so this is our workflow, our pipeline. Because for each proceeding, we take the contributions. We have a service for name entity recognition, as Christian told you, because sometimes in the contribution there's some kind of like this spot is very nice. Thank you very much, Heinrich Müller. Yeah? So you have a name, and we as a city department, we don't want to handle any kind of personalization. This is why we have this name entity recognition system. So we extract the key messages, we make the statement labeling. We use Lamine 3.1 for this. So it's an open source model. For the statement labeling, we have trained a Word model. We classify the key message type. This is this one. It's the wish, problem, quality, and neutrals, and our statements. Then we categorize it with our category classifier, and for each of these categories, we cluster. All right? And we do the title generation. Also what we have done is, because our stakeholders know that in clustering there are different algorithms you can use. And one algorithm that we have used is you need a parameter. Yeah, it's called K. So, but you can play with it, yeah, and you can do some kind of mathematical magic, I would say, all right? So to estimate what this K can be, to get a nice cluster out of it, all right? So that's why we have an estimator as well, and we'll see that in the application. Yeah, and then we just generate the title, so we have this cluster of aspects with a title, all right? So we have a very condensed type of content, yeah, from these contributions. All right, yes. So we have two kinds of layers in our setup, or actually three types of layers. So the one layer is the Drupal side. Then we have some kind of middleware, which is our orchestrator, which executes pipelines, because as Christian told you, there's some kind of trigger that triggers the analysis pipeline, which takes all the contributions, extracts the key messages, classifies the categories and so on, which I have told you already. And then, if this is done, we push it back to the Drupal layer. Yeah, so it's saved there. And after this, we get the key messages from the Drupal system, and we have our aspect generation, which is this clustering process. Yeah? But we get this, we estimate the K as parameter, I told you, and we set back the result. Yeah? So we have this aspect with the cluster. And we have also a name entity recognition. This is more for the live monitor. As I told you, sometimes you have this privacy data. This is the middle layer, the orchestrator. And then we have the third layer, or NLP services. And these services are just, you can use it for everything they state here. So like for key message extraction, stable labeling, category, and so on. They are not dependent on actually on participation data. Yeah? They are some kind of tailored to this, but you can change out the prompt, and then you can use this as well for other kind of applications, right? So this is because our philosophy is to not demand too much on the system, yeah, and also we want to provide it to other cities. That's why we have this. All right. Okay, let me see if I can get. Yeah, there's no internet on here. Okay. All right. Maybe I can set up the hotspot. Otherwise, I have it on slides, but then it's only screenshots. So give me just 1 minute. okay. So
Aber verbinden kannst du dich mit dem WLAN, das hat noch keinen Internetzugang. Du kannst dich mit dem WLAN verbinden, aber du kommst nicht ins Internet raus.
okay, so here you can see our tool. So this is the view for our customers or urban planners. All right. You have here.
Das ist eine Kategorie View.
Yeah. For example, you have here the category, or all the categories, right? In this folder icons. And for example, I can go to, so this is, the word is Bildung in German, it's education in English. I can go, for example, to this, where you can see, and as I told you, every contribution has this geo-reference, right? So you can see here all the points that are in this education cluster. Right? Or, for example, another thing I can show you. This, let me see that. For example, sport. Yeah, I'm a big sports fan, so let us see sports. And for example, we have this aspects like more sports and free time areas. Yeah, required. And if I go here, yeah, I can see these 3 points. And as Christian told you, we have integrated our other product, the master portal. And as we told you at the beginning, our department, we're collecting data, we analyze data, we provide applications. And also we're collecting data about sports, like sport places, right? So as a city, we need to know where are sport places. And you can see here. So this, for example, is data about. So I need to scroll a little bit out. But for example, all the green things here are sport areas, all right? So as an urban planner, I can see, are there any sport areas near around these contributions, or this point of interest, right? And for example, you can see here, where it's only this one, and this is one sport area, okay? So, hello? Yes, as well as we have a summarization about this aspect. So you can see as well, this is AI generated, and this is similar here, all right? So as Christian told you, have this undo redo thing, and we have always this human in the loop, so you can go and change it, yeah, for example. We have the summarization, like this aspect comes from 4 parts of sentences, yeah, and from 3 contributions, okay? And there are 20 comments around these contributions, yeah? And you have this kind of controversity scope. So we are currently working on another system. All right, you can also see here downstairs. Like here, the different sentence parts. Yeah? So you always have this kind of relation to the contribution and to the original data. Yeah. Also, Christian has implemented this kind of toggle here, so that you can say, okay, I want to work on that or not. And then you can, ich muss eins zurück, ne?
So even when you now type in the exact same address on another tab in the same browser, you will notice you're not able to edit in this tab. You're only able to edit in the first tab.
Yeah, so it's locked because one proceeding, and actually we have talked about this because there was some kind of concern. What is if there are 3 or 4 people who want to work on the same proceeding, and our stakeholders, no, that's not happening. Usually it's one person. If it's 2, that's okay. They have to wait. So yeah, that's why we have implemented. Ich wollte noch sagen, das Label. Yes.
Is Drupal internet function you have in your municipality? Like Drupal is the platform you have internal communications?
Sorry?
Intranet.
Intra?
You know the word intranet? Internet, intra.
Intranet. Well, not exactly. It's not exactly intranet. It's internet-based, so it's out there on public servers, but you only can access DIPAS Analytics if you have actually an account in the Drupal system and are also enabled for a special proceeding. So,
with employees of the municipality,
yeah.
no one else.
No.
Yeah.
It's just, maybe I should elaborate more a bit on participation types. By law, governments in the EU, I guess in the EU altogether, are required to do participations when a project exceeds a certain value. So there's a threshold. Maybe, let's throw out, if a project costs more than 5 million euros, citizens have to be involved. For these type of participations, there are strict rules implemented by law on how and where and in which type citizens have to be involved. So DIPAS is not a software to address these type of participations. We act on participations or on project where participation is not formally required, but as I mentioned previously, letting your citizens participate and bring their own beliefs and points is quite nice. So this is like an open, more unregulated form of participation, and it's not, you cannot enforce anything which which citizens have provided as information, so it's not enforceable. So they can place their opinion, but the city or the government decides which parts are taken into account. And therefore, it's all internet-based, but the analytics data and all those functions are only accessible after authenticating with an account.
Yes. So yeah, just another feature. As Christian is talking, we have talked about this human in the loop, and you can just say, okay, because sometimes, you know, the AI can be wrong. Yeah, and so you as a proceeding owner, worker, can change.
Okay.
Okay. Yeah, you can change the label. All right. So. Okay, so let me check. I think I've showed you everything. So yeah.
Are there any questions?
Any questions?
the proceeding is ready for analysis at all, and which AI plugins are right now ready to run their analysis. And we have another orchestrator that was quite a funny thing between us two on the LLM side, which handles their pipelines, and they talk to each other over HTTP.
And this is a custom build orchestrator.
Sorry.
It's a custom build orchestrator. Or is it a Kafka, something that receives the data to against best pipelines to the
So the AI, it's both custom. So it's a custom orchestrator because you get the request from the Drupal system, and the orchestrator just get the request, get back, push back to the ID, so the Drupal system knows, okay, this is ID, and ask some kind of status about it, and then the orchestrator, the AI orchestrator, will call the MCP services. The AI services. So for the text analysis.
So we have Drupal side handling like dependencies and orchestration of services, and we have LLM side handling all those services. So each side handles their own dependencies. Okay?
Thank you very much.
You're welcome. Thank you for your interest, guys. Have a nice day and stay tuned.
Ich bin kurz auf Klo, ne?
Ja.
Also, seid ihr noch kurz hier, ja? Lass uns kurz hier. Da kommt das nächste Ding.
Was tun wir jetzt?
Aber ich glaube, das nächste ist sogar hier, wo ich hier bleibe.
Was kommt denn als
Was kommt denn als nächstes?
Jetzt kommt Beyond Chunk and Pray, Smarter Rack und Drupal AI, von Drupal AI. Und ansonsten gibt es nichts mehr hier. Und hier ist Drupal AI Module V2.
Nice, ja.
Achso, okay.
Ja, ist gut.
Oh ja. Rack war dieses Refined AI.
Genau, so sozusagen, das halt ins Internet connected, um aktuelle Versionen Informationen zu haben.